Hi everyone, Old Boy here. Croiso, Fulcher, welcome back to the channel. Apologies for the delay between the last episode. I had some computer issues which saw my computer being out of action for a couple of weeks. Then I was revising for a Attic Greek exam, so that took a lot of my attention. We're going to be picking up where we left off. We're following the thread of the Phoenicians in Britain. And just to bring us back up to speed, to give us a little bit more context about the place we're going to be discussing today, because we're going to be looking at some geology. I'm just going to read what Wikipedia's got to say about the Scilly Isles, just to give you some general overall information about it. Okay, the Scilly Isles, early history. Quote, the islands may correspond to the Kassiterides, the Tin Isles, believed by some to have been visited by the Phoenicians and mentioned by the Greeks. However, there is no evidence of substantial tin mining activity on the islands. The Isles were off the coast of the Brittonic Celtic kingdom of Dumnonia and its later offshoot Kurnow, which is an old name for Cornwall, and may have been a part of these polities until their conquest by the English in the 10th century AD. It is likely that until relatively recent times the islands were much larger and perhaps joined into one island named Enor. Rising sea levels flooded the central plain around 400 to 500 AD, forming the current 55 islands and islets. The word Enor is a contraction of the Old Cornish en Noa, which is a mutation of Doa, meaning the land or the great island. Evidence for the older large island includes a description written during Roman times which designates Scilly as Scilonia Insula in the singular, indicating either a single island or an island much bigger than any of the others. Remains of a prehistoric farm have been found on Nonor, which is now a small rocky skerry, far too small for farming. There once was an Iron Age British community here that extended into Roman times. This community was likely formed by immigrants from Brittany, probably the Veneti, who were active in the tin trade that originated in mining activity in Cornwall and Devon. At certain low tides, the sea becomes shallow enough for people to walk between some of the islands. Ancient field walls are visible below the high tide line off some of the islands such as Samson. Some of the old Cornish language place names also appear to reflect past shorelines and former land areas. The whole of southern England has been steadily sinking in opposition to post-glacial rebound in Scotland. This has caused the rias, which are drowned river valleys, on the southern Cornish coast, for example, the River Fal and the Tamar estuary. End quote. Okay, so a couple of takeaways there. We've got reference of the Veneti tribe. Again, they keep cropping up. They are designated a Celtic tribe that inhabit Brittany. They had a large fleet of ships. They were merchants. They were involved in the tin trade, so we're going to be looking at them further down the line. And we also need to bear in mind that around 400 and 500 AD, that this island's actually sunk beneath the sea slightly, and that it could have potentially been one large island at one time. So here's a map of the Scilly Isles for those of you who don't know where it is. Some of my overseas friends. You can see it's just off the southwest coast of Cornwall there, and I've marked out Brittany as well because this is the British colony that we keep referencing, so just so you've got a little bit of context there. And actually, if we look at an artist's impression of what the Bronze Age Scilly coastline looked like in 3000 BC, an estimate of what they think that could potentially have looked like, if you compare it to a satellite image, it looks like you can actually see that submerged old coastline just beneath the waves. So that's actually not a bad guess really of what it could have potentially looked like. So that's interesting. So the name Kassiterides, it means Tin Isles, and some people obviously have identified the Scilly Isles and they think this is the place that the Greeks and Phoenicians were talking about. So just to recap, I showed you using Perseus Toft's lexicon how kassiteros means tin in Greek. Kassiterinos means made of tin, and then beneath that we have Kassiterides, and again it says the Kassiterides or Tin Islands. So that's how it links to tin, and it's interesting because a part of the word makes its way into the name of a mineral, cassiterite. So what is cassiterite? Well, let's have a look at this article from Geological. Quote, cassiterite is a tin oxide mineral with a chemical composition of SnO2. It is the most important source of tin, and most of the world's supply of tin is obtained by mining cassiterite. Small amounts of primary cassiterite are found in igneous and metamorphic rocks throughout the world. It is also a residue mineral found in soils and sediments. Cassiterite is more resistant to weathering than many other minerals, and that causes it to be concentrated in stream and shoreline sediments, end quote. Okay, so you can see how that Greek word makes its way down into the word for this mineral, which is the primary source of tin today. So that's interesting, isn't it? So let's just build on top of that. Here's another article by Britannica, just to explain it again. So, quote, Kassiterite, also called tinstone, heavy metallic hard tin oxide, that is the major ore of tin. It is colourless when pure, but brown or black when iron impurities are present. Commercially important quantities occur in placer deposits, but cassiterite also occurs in granite and pegmatites. Early in the 15th century, the cassiterite veins in Saxony and Bohemia were mined for tin. Peak production occurred there in the 17th century. In the 18th and much of the 19th centuries, the very large vein deposits of Cornwall were the major source of tin, end quote. Okay, so it occurs near granite, igneous rocks, in sediments, and we also have reference to it being found in these placer deposits. So placer deposits are also known as alluvial deposits. So let's just have a quick look at placer mining. This is just a general overview from Wikipedia again, just to give you a bit of background. So, quote, placer mining is the mining of stream bed, which is also known as alluvial, deposits for minerals. This may be done by open pit or by various surface excavating equipment or tunnelling equipment. Placer mining is frequently used for precious metal deposits, particularly gold and gemstones, both of which are often found in alluvial deposits. Deposits of sand and gravel in modern or ancient stream beds, or occasionally glacial deposits. The metal or gemstones, having been moved by stream flow from an original source such as a vein, are typically only a minuscule portion of the total deposits. Since gems and heavy metals like gold are considerably denser than sand, they tend to accumulate at the base of placer deposits, end quote. Okay, so what it's saying is tin oxide, it is typically found in a vein in the rock. Water can break fragments of them off. Initially they're carried by the current because the current's strong at that source. Because they're quite heavy, as the current diminishes, the weight and the gravity of the mineral causes it to fall, and they form in these sediment piles. So just to give you a bit of background. So let's have a look at these alluvial deposits then. See if there's anything stands out. So this is from Britannica.com again. Quote, alluvial deposits. Material deposited by rivers. It consists of silt, sand, clay and gravel, as well as much organic matter. Alluvial deposits are usually most extensive in the lower part of a river's course, forming floodplains and deltas, but they may form at any point where the river overflows its banks or where the flow of a river is checked. They yield very fertile soils, such as those of the deltas of the Mississippi, Nile, Ganges, etc. They contain most of the world's supply of tin ore, as well as in some regions gold, platinum and gemstones, end quote. Okay, so these alluvial deposits occur coastlines and in floodplains. They typically yield a very fertile soil. So what's interesting is we know that the submerged part of the Scilly Isles seems to indicate that it was a fertile plain, and there's still remnants of, farm walls and such. So that does actually tie in there. Okay, so any evidence for tin? Well, this is a text that I found by the Environment Agency, who were writing about the Scilly Isles. I'm just going to read the introduction to it, and I'll leave the rest up on screen for you to read. Quote, the Isles of Scilly are formed of fractured granite, with overlying blown sand and alluvium in some areas. The surface of the granite has been very highly weathered. Groundwater flow through the fractured granite is very rapid, end quote. Okay, so we have mention of our granite and the alluvium here, so the conditions are looking like they could be right. What about the actual presence of cassiterite then? Well, I found this experiment that was conducted, so these guys went out into the field and they've done an investigation. It's called Evidence of Tin and Tungsten Mineralisation in the Isles of Scilly. It was conducted by J.B. Grant and C.W.E.H. Smith in 2012, and they actually confirmed there was in situ mineralisation of cassiterite. I'll just read out the start of it. I would urge you to go onto the website and look at it more in depth if you want more information on that. Quote, in the present study, sporadic reports of cassiterite on Scilly over the last 2.5 centuries have been confirmed and in situ mineralisation has been recorded. Tungsten mineralisation has also been shown to be present. End quote. Okay, so we've got some indication that there's a presence of certainly some cassiterite anywhere. I don't know exactly how much was there. We also have the alluvial deposits and the granite rock. Now, what about the mining? So we read earlier that there wasn't much to indicate a large mining operation. So I've actually been looking at this alluvial mining, and it actually seems very similar to how you would pan for gold. So this article off rockher.com was discussing placer deposits and mining, and this is a reference to alluvial diamond mining. So I'm just going to read this out for you. Quote, alluvial diamond mining occurs in riverbeds and beaches where thousands of years of erosion and natural forces such as wind, rain and water currents wash diamonds from their primary deposits to beaches and riverbeds. Some alluvial deposits are from long ago rivers. Mining alluvial deposits can be as simple as panning through gravel in a stream and as complex as larger projects that divert rivers to expose diamond-bearing gravels. End quote. Okay, so it doesn't have to be large-scale mining. You can simply pan for it as you would gold, and the sediment would wash through the sieve, leaving you chunks of cassiterite or it sat in the bottom of the sieve. And I also found another article that was written on researchgate.net by somebody called Foreman Bandama. He's got a PhD in anthropology and he actually works for the Field Museum of Natural History in South Africa. And he was actually writing about alluvial cassiterite mining. And I've just included an image here that he used. And this is panning for alluvial cassiterite in India using bamboo baskets. And the next photo on the right there, this is a photograph of alluvial tin miners in the Kalimbi tin mine in South Africa. So as you can see, it doesn't need to be massively invasive. It could have been as simple as a lot of manpower, a lot of panning originally, and I'm guessing with the actual mining in Cornwall, it's showing that the cassiterite is there in these veins, and there obviously some of it gets eroded and washed down shore, so it could have been how it was originally found. You know, they could have known that this erosion was carrying the cassiterite ore to these alluvial deposits, and they may have known that it's coming from somewhere. That's led them to investigate further to find the primary source of this cassiterite. Okay, so that's going to wrap us up today. I just wanted it to be relatively short because I know a lot of you aren't here for geology, but if we're going to be pursuing this thread and investigating it, then it's information that definitely needs to be considered. So just to recap, we know that cassiterite is found near igneous rocks and granite. We know that it's found in alluvial deposits which occur in stream beds or coastlines. We have an indication of those two things for the Scilly Isles. We also know that the panning for the cassiterite doesn't necessarily have to be massively invasive, so I don't know how much of a record that's going to leave, especially bearing in mind that this is, you know, potentially a good couple of thousand years ago plus, and it could have been as simple as just a lot of manpower sieving for the cassiterite, and we also have to factor in that the water level is certainly higher today than it would have been pre 400 500 AD, and this is where the fertile plain is, which sounds like potentially a big alluvial deposit. That indicates to me that further investigation will be required, especially in this area that's now below the water. So anyway, I hope you found that interesting. It's a key area of study, so we can't neglect this type of thing. And next, we're going to be looking at some archaeological evidence, so definitely stay tuned for that. I've got a couple of good sources to show you. So thanks for tuning in once again. I hope I got my point across today, and I'll catch you for the next one. Oh boy.